Assalamu alaikum. My name is Maksud and I'm currently doing mechatronics engineering from A University Islamabad, and today I'm here to show you my lab 10 of microcontroller and embedded system. From basically lab 10 onwards we had to do work on FPGA. So basically, and we had to code its Verilog HDL in Quartus version 13 or 15. So basically, first of all, I will let you know what is a FPGA. So basically, FPGA stands for field programmable gate array. So basically, it is much more advanced and much more efficient than microcontroller than Arduino, because it has everything already installed in it. It has 7 segment display. It has 7 segment display installed in it. It has USB ports. It has different specs more than microcontroller. So basically, FPGA is much more complex but much more efficient than a simple microcontroller. So basically, FPGA essentially is a huge array of gates which can be programmed and reconfigured anytime, anywhere. So basically, huge array of gates, we can describe FPGA as huge array of gates. So basically, FPGAs are built in hard blocks as memory controllers, high speed communication interfaces. As I told you before, it is much more efficient. So basically, it has everything already installed in it. So basically, there are many applications of FPGA, as and it has been proven that it is very costly as well. So basically, these are the applications of FPGA: high performance computing, AI, artificial intelligence. So basically, military and space applications. So we use this FPGA in very great models, in very great projects. So basically, now as I told you that we had to code for FPGA in Quartus 15 in Verilog HDL using Altera model, same architecture. So basically, uh, a Verilog. So first of all, I will let you know what is a Verilog. In The reason is that FPGAs are much more than just a bunch of gates. While it's possible to build logic circuits of any complexity simply by arranging and connecting logic gates. So basically, two popular ways to accomplish this are schematic entry in HDL's hardware description language. So basically, this is a hardware description language. That's why we had to code in Verilog HDL for FPGA. I will let you know how we can code it in Verilog HDL. So basically, this is a very simple language as compared to other languages for me. So Verilog is a hardware description language, can be used to describe digital circuits in a textual manner. I will let you know how we can code in Verilog HDL. So what is an RTL? So I will show you this command also in Quartus. So basically, it is used for checking simulation of our code. RTL is stands for register transfer level. You might incorporate the terms register transfer logic or register transfer language. They all mean same exact. And RTL is a high level of abstraction of a digital hardware design, comes somewhere between strictly behavior modeling on one end and purely gate level structure modeling on other ends. So basically, as I told you before, that is, it will be a kind of simulation for our code, that how we can implement it in FPGA. As I told you, what is a model sim? Model sim is a multi-language HDA simulation environment. Before Quartus, we had to do coding in model sim Altera. So now, as it has progressed, so we had to do it in Quartus. So simulation environment by Mentor graphics for simulation of hardware description, such as VHDL, Verilog, and System C. So basically, there are many ways how we can code a program after Altera Quartus 2. As I told you, we had to do it in Quartus 13 or 15. This is the older version of Quartus. It is a programmable logic device design software produced by Altera before Altera was acquired by Intel and tool was renamed to Quartus Prime. So basically, this is a software in which we can also check waveforms, we can check its software simulation, we can run the code and for FPGA. So basically, this is a software for that. There are many features of FPGA. And first of all, in this lab 10, we had to install Quartus. We had to click on Modelsym um, setup. So basically, I have done all these steps before this lab. So basically, these are all the steps by which we can download Quartus. Now I will show you how we can run Quartus. So basically, we have to open Quartus, and this when you click on a create new project, this will appear. So this is basically the place where you want to save your folder. Let's suppose I want to save my file on desktop. So basically I will select folder, and what is name of project? For example, I call it lab 10. So basically this will be my project name. I will click on next, then next again. So this page will appear. So basically now I will click on Cyclone 2, because it is much faster than Cyclone 5. For name filter, we were given a name of the architecture, which was basically one second. Yes, this EP2C. I will copy it here and I will name filter for it. So basically this is by architecture which I want to use in Cyclone 2. Here in simulation I will select Molder Sim Altera, and here I will select Verilog HD, as I told you before that we will work on in Verilog HDL. So I will click on finish. So this lab 10, I guess this project can't be opened because I have already used this name in that place. So let's open a new let's open an old project. As you can see, I have opened lab 10, and when I click on this code, so this code I have already pasted this code in here, which was based on arithmetic, sorry, logical operations based on and, or, and not. So basically this was my code and I've named it lab 10 1. So whenever I run this code by using control L, it will be compiled successfully, as you will see in here. So basically, as you can see, this compilation was successful. So whenever I click on this command, loading pin planner will appear. So this means that this is our basically structure of FPGA, and we have to connect, we have to give it pin number and connect accordingly on our hardware. So basically this is used for pin planning. And now when I will click on this load and locate, and as I told you before, what is an RTL? So locate in RTL we will, and it will kind of give us a simulation, software simulation of our code. So basically now when I will click on file new, and here I will click on university program VWF and insert node or bus list, transfer it here. Okay, and then when I let's check if which are our input and which are our output. So basically A, B, C are our input. So let's suppose I give 100 period to this. We have to give them on equal basis, that is we have to equally divide them period, like dividing by 250, and I'm giving C 25. So when I will run my waveform, save it here, and you will see it will be successfully compiled. So this window will appear, and as you can see, these are all my outputs. This is A, this is my input, B is my input, and C is my output. Rather D is my output, E is my output, F is my output. So basically it works that way. And F2. So these are all my outputs for these kind of inputs. So this is how Quartus works, and I will run my other tasks as well in lab 11 and 12 and 13. So basically this was our manual and we had to run these. So basically the main objective of lab 10 was to know what are these softwares and how we can work on them. Thank you so much.